Hey subscribers, welcome back to another episode of Science with Surbeck. Today what we're going to be doing is some extra freezing point depression and boiling point elevation practice. So what I'm going to do problem number 1, and then I need you to do the remaining problems 2, 3, and 4 on your own. So remember a couple of things with our freezing point depression and our boiling point elevation. They're going to have very, very similar formats or very similar formulas, and they are going to look like this. For the freezing point depression, the formula that we're going to use here is delta TF equals KF times your M formality. Now, your boiling point elevation is going to use delta TB equals KB times your M for molality. Now, because both of these use M for molality, we should be able to, or we need to be able to solve the molality of this particular problem. So this problem says here, using the information in the periodic table packet, calculate the freezing point and boiling point of a 12-gram sample of glucose in 50 grams of H2O. Well, remember here, if we're using molality, it is going to be little m, and it's going to be moles of our solute divided by kilograms of our solvent. Now, our solute is going to be glucose, or C6H12O6, and our solvent is going to be that of water, or H2O. And so we're just going to plug these values in, or find these values here, and we're not given directly molality, nor are we directly given moles of our particular solute, but we are given grams of that solute. So we're given 12 grams of the solute, and we need to get it to moles. Now, we set up our conversion, and remember, grams of glucose would cancel, and on top, we would end up with moles of glucose. Now, you can use the periodic table and calculate the molar mass of glucose, but I went ahead, I just looked it up for you, and it is 180.16 grams per mole. Okay, so our 180 number here is going to go on bottom. Okay, so we're going to have 180.16 per 1 mole. Now, I'm going to get out my calculator, and we are going to take 12 divided by 180.16. So 12 divided by 180.16. Press enter, and rounding here I get 0.0667. So that's 0.0667 moles of our glucose. So again, this would equal 0.00667 moles of our glucose. Now, to save a little time and space, I'm going to go ahead and just plug our 50 grams and convert it in the calculator to kilograms. So again, all I'm going to do here is take 50 divided by 1,000, and that is to get our grams of water into kilograms. So right here, this is what I'm going to write down, is that our 50 grams of H2O, right above here, I'm going to write down 0.05 kilograms of H2O. That is going to be our kilograms of our solvent. So let's plug this all back together. So our molality here is we have 0.00667 moles of glucose divided by our 0.05 kilograms of H2O. Now, we take this into our calculator, and we have 0.00667 divided by 0.05. We press enter, and we get a molality. We get a molality. Let me double check this here. Oh, yep, I made a slight mistake here. And the mistake I made here, I wrote down one too many zeros when I took my moles of glucose. So I'm just going to backtrack a little bit. 12 divided by 180.16 is 0.0667. I got a little happy with the zeros there, so it should be 0.0667. Okay, so our moles of our solute or glucose is 0.0667 moles. Again, just a minor mistake here, but it will affect our molality. Again, 0.0667. Okay. Okay, so now we're back on track here. We are going to take 0.0667. All right, there we go. Divided by 0.05. We press enter, and to 3 significant digits, we get 1.33. So your molality that we're going to use throughout this entire problem is 1.33. Now, the reason we took the time to do that is because the molality for change in freezing point and change in boiling point is going to be the same molality. Now, our delta TF is going to be what we're finding. That's our question mark. And our KF, anytime we have either a freezing point constant or a boiling point constant, it is going to be of our solvent. So our solvent is water. So our KF, if we look on our chart, our periodic table chart here, and we find water and we find KF, we see that it has a value of 1.86 degrees Celsius per mole, or degree Celsius per, that is M for molality. Okay, so this right here, our KF, would be 1.86 degrees Celsius per M for molal. Again, that's going to be very helpful. And then our molality that we just got done calculating is 1.33 little m. So let's go ahead. We'll solve for delta TF. And so we're going to take our KF, which is 1.86 degrees Celsius per molal, times 1.33 molal. So we plug that into our calculator. 1.33 times 1.86. We get a value here. I'm going to round to 3 significant digits of 2.47. So our delta TF is equal to 2.47 degrees Celsius. Now, that is not our freezing point, and that is because the normal freezing point needs to be factored in. So the freezing point of pure water, which is our solvent, is 0 degrees Celsius. However, we have depressed, or we've lowered the freezing point. So our freezing point, which I'm going to label FP for water, you always use the value here of the normal freezing point, which for water is 0 degrees Celsius, and you subtract it by what your delta TF was. So your new freezing point for water in this case would be negative 2.47 degrees Celsius. Again, that is negative 2.47 degrees Celsius. And that would be our final answer. You have to subtract it from 0 because that is water's, or the solvent's, normal freezing point. Now, I want to make a note here that these K values of both KF and KB is the K for pure solvent, okay? Not the solute, but the solvent. Now we're going to do a very similar thing for our change in boiling point temperature. So again, delta TB is going to be our question mark here. Our KB is the boiling point constant of water. So again, we find water, and we see here that it has a value of 0.512 degrees Celsius per M. Okay, so this is 0.512 degrees Celsius per M. Now we established that our molality is 1.33 molal. 1.33 molal. Now we plug these values back in and we solve for delta TB. Again, delta TB is change in boiling point temperature. So we take 0.512 degrees Celsius per M times 1.33 M. Okay, so I know it's squeezed here, but what I'm going to do in my calculator, I'm going to take 0.512 times 1.33. And our delta TB is 0.618. Again, by the time we round, delta TB here is 0.681. Delta TB equals 0.681 degrees Celsius. Now, I'm running out of room here, but to find the boiling point, which I'm going to bring it down here, to find the boiling point, what we need to do here is we need to look back at our chart. Our pure solvent, in this case water, boils normally at 100 degrees Celsius. However, this formula says, hey, the change in boiling point or the elevation in boiling point means we need to add whatever we got here with delta TB to our boiling point. So our normal boiling point is 100 degrees Celsius plus the change in that boiling point, which we just calculated to be 0.681 degrees Celsius. So our boiling point here, our new boiling point from our solution, would become 100.681 degrees Celsius. And that would be our answer. So the key thing here, find your molality. Then what we need to do here is this. Freezing point. When we find the delta TF, you're using the KF for that pure solvent. Then you have to subtract that delta TF value that you find from the normal freezing point. For our delta TB, same type of process. It is going to be a new value for KB. We can't use that same value. And instead of subtracting, we add to that normal boiling point. So you need, in these types of problems, to analyze what substance here is your solvent. Again, this is pure solvent that you can find your KF, KB, and your normal freezing and boiling points. Keep that in mind because as you go through these problems, we vary the normal or we vary the solvent. So that's going to affect your normal freezing point, boiling point, and those K values. All right, so take your time. Remember, we need to utilize this information here or these formulas, but once we find that delta T value for either freezing or boiling point, we need to subtract or add it respectively to the normal boiling and freezing points. All right, I hope you have enjoyed this particular episode. And as always, if you have not done so already, make sure you subscribe.